Hi, my name is Blaž and I'm a product manager at Metrel. Today we go through all the accessories you get in the MI3325 Multi-Servicer XDIS Euroset, and we will take a closer look at the most important features and functionalities of the instrument itself. Let's begin by explaining what is included in the standard set. So, inside the box we get our test instrument, which is packed in this rugged case, and we get also the bag with the belonging accessories, which is intended to be placed here on the cover of the test instrument. So let's now look what is hidden inside the bag with accessories. So what we get here is the two of the high voltage test leads, of course intended for execution of the high voltage test with test voltages up to 5.1 kV AC, and these two test leads are intended to be used together with test tip and the high voltage crocodile clip. Then inside this bag we have all sorts of different crocodile clips as well. This is important for connection to the tested objects. Then we have two communication cables, the serial one and the USB one. These two are inside for communicating with the PC software Metrel Electrical Manager, Electrical Safety Manager, or also for this serial cable can be also used for connecting our test instrument to different accessories. Then we have this 1.5 meter long test lead, which is intended to be used when performing tests with a probe, for example, two-wire continuity test or insulation resistance test with probe, and others where probe is required. Then inside the next bag, this here is the cable for testing residual voltages. This is very important to remember because the connection cable on this cable and the other cable, which is let's say the universal test three-wire test cable, these are the same. But if you would like to test residual voltage, you should use this specially dedicated cable. So then the next one is this three-wire test cable, which is intended to be used for tests on the, let's say, for the installation safety, so the impedance tests, insulation resistance, and other tests, but we will explain this during the presentation of the instrument itself. The next two test leads in the set are the ones that are intended to be used for the four-wire earth continuity test. Those two are 2.5 meter long. Then the last bag here. Inside here we have two ISC leads. One is intended for the power supply of the instrument, and the other one can be used for testing extension leads that may also be RCD or PRCD protected. Then is this special plug cable, which is designed again for testing safety of electrical installations, where we have sockets that we can test via this universal test cable. Now that we have successfully mounted this our back with accessories to the test instrument, we can also check what is hiding inside the instrument's cover. So here we can see that the instrument comes supplied with the instruction manual. This is a short version, but printed, of course. Then the instrument comes also supplied with the calibration certificate for all the measuring functions. Then there is a special paper with the information about all the belonging accessories of the standard set. The next one, it's the paper with the administration password. Make sure that you keep this one on the safe place. And a special paper with different information about optional accessories and other features of the material product. Okay, so let us now focus on the description of the instrument's front panel. So on the left top corner there is a port for supplying the test instrument. Below we have the on-off switch and the fuses, which are protecting the instrument supply circuit as well as the main test socket. After the fuses, it's the location of the ISC connector and also, as I said, the instrument's main test socket. Now, the ISC connector and the instrument main test socket can be used for testing different extension leads, IAT test leads, and also leads that may be RCD protected. Then, beside the instrument main test socket, it's a special test terminal dedicated for tests where the probe is needed. So, for example, earth continuity test with two-wire test method, or insulation resistance with a probe, so basically for the class 2 devices. Then the main front panel, where it is the location of different communication ports and the touchscreen LCD as well as the keypad. So on the left side of this main console we can find the Ethernet communication port, then the USB communication port and the location of the SD card. Ethernet communication port, USB communication port and the PC serial port can be used for communication between our test instrument and the PC software Material Electrical Safety Manager, as well as for the communication with the external black box protocol, which enable us to use the instrument as a black box and execute all the measurements via this communication protocol. Then the communication ports mentioned can be also used with the SDK protocol. Let's check the other communication ports now. The RS232-2 can be used for connecting the external optional accessories, the wired ones, so the wired scanner or scanners or printers, and the other two communication ports, the inputs and outputs, can be used for connecting external LED signal lamps or the external remote pedal and the external remote tip commander. These inputs and outputs ports can also be programmed on the PC software side. The MESAM or the Material Electrical Safety Manager has a special module for the editing of the auto sequences, and inside that module we can decide how to correctly program inputs and outputs, so they can be used as a logical circuits for controlling external devices. If we focus on the right side of the instrument, at the top there is a special port dedicated for connecting optional current clamps and a multi-purpose TP1 connector to which we can connect the test cable for measuring residual voltage or the universal 3-wire and Schuko cables for testing either discharging time, so the residual voltage, insulation resistance, or line loop impedances plus the RCD testing. The next one is the continuity test terminal, where we connect the 4-wire testing leads for testing, of course, 4-wire continuity. And the last one is the high voltage test terminal, from where we can perform the high voltage test with up to 5.1 kilovolts AC. Okay, let's now check the instruments menu. So as you can see, there are 4 groups and in the main menu, and we will first focus on the general settings. Inside the general settings, we can select between different language options. Then, of course, we can adjust date and time. Make sure that this is adjusted before start using instrument. Why is this important? Because the time and date stamp will be dedicated to every performed measurement, and for the traceability of test results, this is of course very important. Then we have two menus, two special menus which are linked into the main menu. So one is the workspace manager, the other is the auto sequence groups. In these two menus we can choose between different workspaces. Now each of these workspaces is a separate database which can be opened in the memory organizer. What is the difference between either memory organizer or these workspaces is that the data which is stored inside one workspace cannot be copied into another one, whereas when we will see in the memory organizer, we can edit all that data. So these are basically our separate databases. This is Workspace Manager. The Auto Sequence Group has similar logic, so we can see here that currently we have inside our Auto Sequence Groups 3 different groups. One is dedicated for testing electrical installation safety, the other one for testing of electrical equipment, and one for testing of machines and switchboards. So if we select one of these, then we will be able to see in the auto sequence group the complete list of the auto sequences. But we will still get to that option later. Then the user accounts menu. This one is also very important because the administrator of the instrument can assign more than several different accounts, and each of these accounts can have a username and of course also a password. Again, why this is important? Firstly, the person who does not have the password cannot access to the instrument, and the second one, which is more important, is that if we log into the instrument, each particular measurement will be signed with the username. Then a little bit larger submenu. This is the settings. Inside here we can, for example, adjust if we want to use touch screen or not. Then we can also disable sounds. Then we have a couple of options which are dedicated to the parameters of special structure elements. For example, we can decide whether we want to increment the ID number, or we want to replicate it, or use the field blank and each time enter it manually. The same option is available also for the equipment name and the retest period. This instrument currently supports only one optional clamps, so there is no option to change it. Earthing system, we can choose between TNTT and IT earthing system. Of course, this affects also some measurements. For this, you will have to check, for detailed information, you will have to check the instruction manual. The same is with the selection of different RCD standards. So if I choose between different options, different limits will be applied to the measurements. Instrument also supports testing of EVRCDs and RCMs. Then the next option is to set the ISC factor, and the next one is the option to merge fuses. Now, maybe a few words about this option, merge fuses. As you will later see, this instrument supports a lot of different measurements, from line impedances, loop impedances, to RCD testing, of course, with different fuse settings. And if we are performing tests on the same switchboard, where of course we have mainly the same type of the fuses, we can say merge fuses. It means that if we are changing between one measurement to another, the measurement will have the same settings as they were set for the first measurement. But we can always decide not to merge them, so for each specific measurement the settings of the fuses will remain as they were last used. The next option is the result. We can decide what type of result we would like to see at the end of the measurement, worst or last. Of course, this setting applies for specific measurements. So again, for detailed information, you have to check the instruction manual. Test mode, standard and expert. This has the effect on the auto sequences. So in case that the auto sequence includes also visual inspection or functional inspection, then in case of the expert mode, these inspections will be automatically filled with the tick, and the instrument will proceed to the next measuring step. In case of standard, of course, the user has to tick and check everything manually, and only then proceed to the next measuring step. Then the next option is has effect on the auto sequence flow. So we have the option to choose end if fail or proceed if fail. This end if fail is typically used when testing electrical equipment, so appliances, periodically. So in case of the fail step, the test sequence, you will not be able to proceed with the test sequence, but it will be automatically finished. If we have the option proceed if fail, this is mainly inside for troubleshooting or testing on other equipment, meaning that even if we have some fail steps, we can still proceed with the testing, and after we finish, of course, appropriately label the parts that failed during the examination. Ignore PE warning. The instrument can be used also on the IT system, and we can here choose to ignore this pre-test, and it will not pop up with the warnings. Then there is an option called contact voltage pretest. This has effect on the IT system. We can decide if we want to calculate the factors, and the next one is to enable or disable load pretest. So in case that we have, for example, on the electrical installation, during the insulation resistance test, that we have some loads installed between live and neutral, the pretest will warn us not to perform the test. But in case that we are testing mainly devices connected to the main test socket, we can also decide to disable this pretest, and, for example, in case of testing extension cords, we will not receive any of these warnings. The next option is for selection of warning lamps. Warning lamps are an optional accessory and can be used for high voltage test. So in case that we are performing high voltage tests, we have the option to choose status ready, in operation and in operation. So for this we have to select just the setting HV lamps. In case that we would like also to see the pass-fail status, then we select the next option. So HV lamps plus the status, meaning pass-fail status. The next one in these settings, it's the option to select to enable external tip commander or external pedal for starting the measurements remotely. As you will be able to see also from our sales materials, this instrument supports a few optional adapters, and here is the list of them. So in case that you are using one of these active adapters, it has to be enabled in this menu. What are the options? The first two options, the MI3144 and the MI3143, are for the impedance adapters. So in case that we are performing measurements in switchboard environments where we need higher currents for performance of line loop impedances, we always recommend to use these external impedance adapters for more accurate measurements. Then instrument also supports the A1632 adapter. This one is specially dedicated for testing electrical vehicle safety equipment, in particular charging stations. The next one are the MD9273. These are the Bluetooth leakage current clamps. And the last one from the list of adapters are the A1322 and A1422 adapters. These two can be used, the lower one just for testing three-phase electrical equipment or three-phase extension cables and boxes that may be RCD protected. And the higher model, it's also supporting testing of welding equipment. Additional adapter which does not need a selection in the settings menu, it's the A1460, and that is the adapter that serves for testing of electrical equipment where we need an automized procedure. The last part, it's dedicated to Ethernet communication. So in case that you would like to select manual setup, select manually, then dedicate all parameters, and the instrument can be connected to Ethernet via custom settings, or simply use the automatic mode. Then the next menu here is the devices. So the instrument itself also supports few optional reading and writing devices. Those devices come in two options, wired or wireless. So the instrument enables to connect via Bluetooth or via serial communication port different devices like scanners, printers, NFC readers. Okay, the next option here is the Bluetooth initialization. In case that some problems happen between communication, we can simply just initialize the Bluetooth module and the communication will be established again. Then the next one is the initial setting itself. This will basically means that the instrument will be set back to the factory settings. Change password menu serves for changing of the high voltage password. The instrument has the functionality that before we want to start the high voltage test, the instrument always require the high voltage password, so only the users that know this password can start the high voltage test. The last one in this group is the about menu. Inside here there are all the needed information for let's say troubleshooting. So in case that you are somehow interested what your instrument enables, what your firmware version enables, you can always ask us. But before doing this, please provide us this information from the About menu. Okay, now let's focus on the auto sequences. Each instrument delivered from Material comes supplied with with at least 3 different groups of auto sequences. I was explaining before, in the general settings there is a special menu where you can choose between these groups. There is also a shortcut in this auto sequence menu. So for example, please pay attention. If I click here on the header of the auto sequence menu and choose the auto sequence groups, it will redirect me back to the general settings menu, where I can see what are the groups, the auto sequence groups available. So the first one is dedicated for safety of electrical installation, the second one for testing machines or switchboards, and the last one for testing on let's say portable equipment or generally electrical equipment with the plugs. If we select now the different group, for example, like this, the instrument automatically jumps back into the auto sequence menu, and now we can toggle here between these auto sequences, which can be organized in the folder tree structure. And of course this is up to the customers. They can decide how to organize this data. The parameters of each specific auto sequence can be also edited before the auto sequence is executed. So here on the right side we can choose the option View, which will show us all the measurement steps of this auto sequence. And of course, if the auto sequence was created in a way that there is an explanation of or some text or some notice, we can also read for what purpose this auto sequence was made. So now on these particular steps, we can see that we can change parameters before we start the test. And of course, if the testing step in particular enabling also multiple points, we can also choose multiple points for this specific testing step. If we say, for example, earth continuity, and we choose multiple points, this means that the instrument during this auto sequence will repeat this step until the loop is finished. So that's basically it about the parameters, and we can simply start the test here. So after the test sequence is started, the user have the option to go through all these procedures. The auto sequence can have built-in pictures, built-in texts, built-in poses. So a lot of options during the auto sequence, but all of this must be made on the PC software side. What is also a nice feature for the auto sequences is the configurator tool, or in our case the calculator tool, where we can decide to calculate the resistance, the limit for the earth continuity resistance measurement, which is automatically calculated based on the length and the cross section of the PE conductor measured. The next menu is the memory organizer. So inside here all the data that was measured is stored. We can always decide how to correctly organize this data. The measurement organizer has quite few options. So we can basically of course create our structure. Then if the structure is already created or a part of it, we can also copy it or clone it. So the cloning, it's a very fast way for performing tests on similar equipment, let's say. We can basically start creating a test structure on the instrument for a new type of machine, and also execute the tests during this creation of the structure. And after we finish and we would like to test similar or same type of electrical equipment, we just simply use the option clone, and the instrument will clone the complete structure, of course without executed measurements. So the next equipment that we go and test, we just follow the measurement steps from the previously tested equipment. Of course, for each structure element that is inside this memory organizer, different parameters can be added. Editing of the parameters is enabled by this option here, and of course all of these parameters that can be found under the specific structure element are then also transferred to the PC software and eventually to the professional test reports. A very nice feature of this equipment is also two ways of testing, let's say. One way is to start the measurements from the single tests or auto sequences, and the other way of testing the equipments is to start from the memory organizer. So as I mentioned, we can simply create ourselves a structure by performing the measurement step by step on specific equipment. If we say we would like to test a switchboard, then we select the option single test, and the instrument will jump into the single test menu, where we select the specific or the required measurement, execute it and save it under that location. Like this, stop and save. So now this is stored inside the memory organizer. This one is colored blue because we didn't set any limit, but how the cloning works, it's like this. Now we have this structure element, and we say we would like to clone it, include structure parameters, etc. We say clone. So now we have a new device here with incremented ID number and still with an empty measurement. So we can simply repeat it, and so on and so on. So now let's focus on the single test menu. Inside the single test menu, you can firstly notice that we have a special filter, which is called area groups. If we select this filter, we can see the applications that are supported by the instrument. So the instrument supports testing of electrical equipment, or let's say portable appliances, then of course electrical machines, switch gears, welding equipment, and also electrical vehicle safety equipment. So all of these area groups are covered by the device, and in case that we are performing tests on just a specific application, we can simply choose one of these options, and the instrument will list us only the measurements that are applicable for that specific application. But let's focus on all the measurements that are supported by the instrument. So once we select all, we can see that inside this menu all the measurements are listed. We at Metrel have decided to support different visual inspections and different functional inspections based on the standards. So once we select one of these options, the result of this inspection will be stored next to the measurement, and also of course printed to the test report. What is important to say, it's also that within auto sequences, these different types of lists can be custom-made by the customers as well, but again on the side of the PC software. For more information about how these auto sequences can be created, follow us on the YouTube channel and search for the part where this is explained. The next group inside the single test is insulation resistance testing group, we have different options. The first one called RISO, AA stands for electrical equipment. If we select this one, the test, the isolation resistance test will be executed via this main test socket, or in case that we are performing it with the probe, then will be again via this main test socket against the probe. We can always decide whether to measure only insulation resistance for class 2 appliances or for class 1, or combination of this test. And we can also choose between test voltages 250 and 500 volts. The instrument also supports, of course, setting of duration and the limits. The next in this group of insulation resistance testing is the one dedicated for the testing insulation resistance on welding equipment. This group is supported only when using instrument alongside with the active three-phase adapter A1422. That's why it is also currently disabled here. We cannot start it. What is the special thing about this measuring function is that we have, of course, different parameters depending on where on the welding equipment the measurement is performed. We can add correct or appropriate parameter. Then we have the insulation resistance test, which is executed primarily via this multi-purpose test terminal. This one is dedicated for testing on switchboards or, let's say, part of electrical installation safety. Again, different parameters can be dedicated and also different test voltages can be used. We can choose between 50 volts, 100, 250, 500 and 1000 volts DC. The last option inside the RISO group is the varistor test. Here we have the option, with this function, we have the option to also check the varistors. We have to use this universal testing port, and of course during the varistor test, the test voltage will be applied to the tested object by increasing the slope and checking if the varistor is okay or not. The next group inside the single tests is the leakage group. Here again we can choose between different leakage current test methods. The first three are dedicated to the PE conductor leakage test with, as I said, different methods: substitute leakage or alternative method, differential leakage or residual current method, and EPA leakage or the direct method. Then, of course, we also support the touch leakage, leaks and power, leakages for welding equipment. These are welding equipment leakage and protective conductor leakage. If we focus on each specific measurement, again, substitute leakage measurement has the same logic as previously shown insulation resistance. So we can perform the test from the socket between phase and neutral conductor against PE, or the test with the probe. Again, here connect the device, and the test will be performed between live and neutral against the probe. So for class 1, class 2 equipment testing, or for the combined equipment testing, or you can always decide to perform these measurements independently. The differential current measurement, for this measuring function, it's important to understand that we also have the option to set change of mains polarity. So for the equipment with Schuko connectors, it is important to measure the leakage current in both directions of mains polarity. And the sub result in this measuring function is also power. Then we have the EPA leakage or the direct measuring method. Inside here we can see that we have also the sub-results for the AC and DC component or DC part of the leakage, as well as the power measurement. Then the touch current, similar to PE leakage current, though this measurement is performed against this probe. Then quite strong measuring function is the leak scent power. Why it is strong? Because in one measuring step we actually measure the touch current, the differential current, and also all the parameters for the power measurement. Then we have, as I mentioned, two measuring methods for testing on welding equipment, which are again supported only when we use the external active three-phase adapter. The next in the line is the earth continuity test. Instrument supports different current levels for execution of earth continuity test, as well as two different methods. One method, the two-wire method, is performed between main test socket P and the PS probe, and the four-wire test method, which is performed via this test terminal. How we choose where to be performed, it's here on the setting output, where we can use either four-wire test method or the PS test method, which is performed here. Then additional option, it's for testing only the IAC leads or the extension leads, and this is the this option here, where the test will be performed between these two test terminals. We can always set the duration and additional parameter air compensation, which is enabling us to compensate resistance which is added manually into this field. Why is this feature nice to have or important? It's in case that we are, let's say, testing four-wire earth continuity on let's say multiple socket outlets, and we would like to deduct the resistance of these sockets. We can enter it here manually, and of course we do not have to reconnect the test leads every single time. For the two-wire test method, there is also the option of compensating the test leads. Power test, this is typical power function with all the needed parameters. Then we have the high voltage option. This is for execution of high voltage tests. Two test methods are available, let's say the normal one and the programmable one. So if using this normal one or simple one, we can simply adjust the test voltage and the duration, and the instrument will apply the test voltage according to the standard to these two test terminals. In case, and of course the measurement will last at least as long until there is any break on the insulation or until the timer is finished. The next option is the high voltage programmable one. Here we can set the starting test voltage and the end test voltage, and of course different times. One timer is set for the start voltage, then the second timer is set for the duration of the ramp, so between start voltage and the test voltage, and the last one is set for the whole duration of the test. If you would like to know something more about these functions or how to connect them, there is always also the help screens. There are also always the help screens available. The next option on the instrument, it's hidden under the other. So inside here we have the measurements such as polarity. So the polarity test can be set for the ISC leads, or we can also test the polarity of the of the three-phase cables when the instrument is connected to the active three-phase adapters. So the next menu is the current clamp menu, where we receive the measuring result from the optional current clamps which are connected to this test terminal. Then the no load voltage, this test again, it's covered only when the active three-phase adapter is connected, and in this case we have to have the A1422, which enables the testing of welding equipment. Then discharging time or the residual voltage measurement. For this particular measurement, as I mentioned early in the beginning of this presentation, it is important to use the brown cable which is dedicated for the residual voltage test. The measurement will return us discharging time and the residual voltage of the tested appliance or machine. The last in this group is the diagnostic test for the electrical vehicle safety equipment, in our case for the charging station. Now, instrument also covers the part of electrical installation safety, so in this case we can measure single-phase or three-phase test systems, and the instrument will return us all the needed measured voltages. RCD testing, this is also a group of the tests supported for the electrical installation safety part and the part of for electrical equipment. So, for example, we can measure the contact voltage on the RCD. Then we can measure the trip out time of the RCD for different types. Then trip out current of the RCD, again different types. Then we have the auto function. This one is quite appropriate if you want to do things fast, because in one measuring step again we will measure the trip out time of the RCD at nominal current, then 5 times of the current and the half of the current, plus at the end we will measure also the ramp and the contact voltage. As you can see inside the parameters, there is an option to measure fixed RCDs for the installation, then portable RCDs if they are a part of the extension leads, and of course different types of this, and also the measurement of the EV RCD. Then, when testing special type of RCDs, there are also two additional functions. So when we are testing RCDs that need to be supplied with voltage for triggering them, we also have to test the P conductor resistance, and for this we have this active P conductor test. And the last option is also to test the portable RCDs built inside the extension leads. Then the part of electrical installation safety further on, we have the measuring functions for test resistance of the fault loop, in case that we have an RCD protection, or in case that we do not have RCD protection in our installation. What is the difference of these two functions is that in case of the RCD protection, the instrument will perform the test with a lower current and will not trip our installation, our RCD out. When using the normal Z-loop function, in this case the instrument will of course apply higher current. Measurement is a bit more precise and faster. Then we have the option of measuring line impedances, voltage drop, or we can also use the automatic function to evaluate most of these parameters just explained. The last measuring function inside the single test is the menu for so-called air-low menu. Again, two measurements for earth continuity, one with the DC current with the 200 milliamps in plus and minus, so the reversed polarity, and the RPE function, which is very convenient when testing earth continuity on the side of electrical installation safety, because in this case the instrument uses the part of the live voltage, and it will perform the measurement with active 200 milliamps between the N conductor in the loop with the P. So again, very convenient function for fast evaluation on the installation site from the test sockets. The last is functional inspection. So measurements, we have measurements and we have visual and functional inspections. Again, according to different standards, different predefined functional inspections are also a part of this menu. They can be saved again under the structure elements, and the information from these functional inspections will be printed on the professional test reports. Well, that's all for today. Don't forget to like, share, comment and subscribe. I'll see you next time.